All right, buckle up, everybody, because today we're diving headfirst into some seriously mind-bending stuff.
Yeah, this one's a big one.
We're talking about the Grand Fibonacci theory,
That's right.
and it claims to explain, like, the entire universe
The whole shebang.
with just one equation.
You got it.
So we're talking everything from, like, the tiniest particles you can imagine to the massive expanse of space.
All with one equation. Pretty wild, right?
It's kind of blowing my mind already, and we're just getting started. But we've got some really interesting sources to break down, so let's jump in. What do you say?
Let's go for it. So one of the most fascinating things about the Grand Fibonacci theory is that it's trying to be this, like, unifying theory in physics.
Oh, okay. I've heard physicists talked about that, like a theory of everything.
Exactly. A theory of everything. Been searching for it for, like, decades.
Right.
And it's trying to bridge this gap that we've had between, quantum mechanics, which explains all the tiny stuff, the subatomic world.
Yeah.
And then general relativity, which is Einstein's theory of gravity, the big stuff, how the universe is structured.
Okay, so instead of having two separate sets of rules, one for the tiny stuff and one for the massive stuff, this theory is saying there's actually one underlying principle that governs, like, everything.
Boom. That's the idea.
Oh.
And, for the longest time, physicists have kind of had to use these separate laws, and then they add in things like, dark matter and dark energy to explain things that don't quite fit.
Yeah, those are such mysteries.
Total mysteries. But the Grand Fibonacci theory is saying, well, hold on a second, maybe we don't need all these extra things.
Oh, interesting.
Maybe these mysterious phenomena that we've labeled dark matter and dark energy, maybe they actually just come naturally from a single fundamental principle.
Okay, wait, so you're saying dark matter and dark energy, these huge mysteries that scientists have been trying to figure out forever, could potentially be explained away by this one theory?
That's the hope, that's the goal.
All right, I am officially intrigued. Tell me more.
So instead of thinking of the universe as this, like, random collection of forces and particles, the Grand Fibonacci theory proposes this really cool concept called wave synergy.
Okay, wave synergy. It sounds kind of like out there.
It's a little out there, but stick with me.
Okay, I'm listening.
It basically suggests that everything in the universe is, like, interconnected. And it interacts through this super complex system of wave patterns.
So were we talking about, like, actual waves, like waves in the ocean?
Not exactly ocean waves. It's a bit more abstract than that.
Oh,
but the analogy can be helpful. Imagine, like, a giant tapestry.
Okay, I can picture that.
And every single thread in that tapestry is connected to every other thread.
All right, yeah.
So the Grand Fibonacci theory is basically saying the universe is kind of like that tapestry. But instead of threads, it's made up of these intricate wave patterns.
Okay, so instead of the universe being this, like, random patchwork of stuff, the Grand Fibonacci theory says it's more like this incredibly intricate woven tapestry. And it's all held together by this wave synergy.
Nailed it. And here's the real mind-blowing part. This wave synergy, this intricate tapestry, it's supposedly all described by a single mathematical equation.
One equation for the whole universe.
That's the idea. It's called the fractal lattice PDE.
The fractal lattice. I'm going to need you to break that down for me a little bit.
No problem.
Yeah.
So basically, it's a type of equation that describes how systems evolve over time, right?
Yeah.
But it's got this key difference. It incorporates this concept of fractals.
Okay. Fractals like
Like a snowflake.
Yes, snowflakes. Okay.
That intricate shape, that's a fractal. It's the same basic pattern repeating itself over and over again at different scales.
Right, I see.
So the Grand Fibonacci theory is suggesting that the universe might be structured in a similar way.
Wait, so you're saying that the same patterns that we see in, like, snowflakes could also be found in galaxies?
Right.
Or even at the, like, subatomic level?
Exactly.
Yeah.
The idea is that this one equation, this fractal lattice PDD, it could actually govern the behavior of everything in the universe. Wow. From the tiniest particles to the largest structures, all through this intricate interplay of wave patterns.
Okay, that's starting to make a little more sense.
Yeah.
But I got to ask, if the universe is governed by one single equation, wouldn't that mean everything is, like, predetermined?
The question of free will.
Yeah, exactly.
So it's a great question, and it's something that the Grand Fibonacci theory is still trying to figure out.
Right.
It doesn't necessarily mean a deterministic universe, though.
Okay.
Think of it more like there's a set of guidelines or constraints within which things can happen. Remember that tapestry analogy?
And of threads.
Right, the threads. They define the structure, but there's still tons of flexibility in how those threads are woven together.
So there's still room for like surprise and change within this system, even though it seems very ordered?
Absolutely. This wave synergy, this push and pull, it sets the stage. But it doesn't dictate every single detail of the play. There's still plenty of room for new things to emerge, for unexpected twists and turns, all because of the complex interplay of these wave patterns.
Okay, starting to get the hang of this now.
Yeah.
But I'm still wondering, what kind of universe does this theory actually predict? Like, does it match up with what we already know about the cosmos?
That's where it gets really interesting because, see, the Grand Fibonacci theory actually proposes a picture of the universe that's very different from the standard model of cosmology.
Oh, okay, so like how we traditionally think about the universe, it's different than that.
Different, yeah. You see, most physicists think the universe is just constantly expanding, you know?
Right, right.
And eventually it's all going to end in either like a heat death,
Yeah.
where everything just cools down and spreads out,
Right.
or a big crunch where it all collapses back on itself.
Yeah, that's the doom and gloom scenario we always hear about, the end of the universe.
Yeah.
So how's the Grand Fibonacci theory different? What does it say?
Well, instead of this like linear progression towards a final end, it suggests the universe is actually cyclical.
Cyclical, what do you mean by that?
So it expands and contracts, but in these vast, vast cycles.
Oh, wow.
Almost like a cosmic breath.
Hold on. So instead of like a one-way trip to oblivion, we're on a cosmic roller coaster.
Kind of, yeah. The universe is constantly in motion, this grand cosmic dance. But what drives these cycles, you might ask?
Yeah, what is pushing and pulling the universe to expand and contract?
Well, remember those wave patterns we talked about?
Yeah.
So the theory suggests that those patterns actually create fluctuations in energy density throughout the universe.
Yep.
And those fluctuations, they drive the expansion and contraction cycles. It's like, oh, this cosmic dance, you know?
So we're not just talking about the universe expanding, we're talking about a universe that breathes.
Yes.
That like pulsates with life.
That's a great way to put it. And these cycles, they could potentially explain some of the mysteries that have puzzled cosmologists for so long.
Like what?
Like, for example, the accelerating expansion of the universe.
Oh, right.
So instead of needing dark energy to explain that,
Yeah.
maybe it's just a phase in this much, much larger cycle.
Okay, that's a pretty big difference from how we currently understand things.
Yeah, it's a big shift.
And it definitely opens up like a whole bunch of new questions.
It sure is.
Like what happens at the turning points of these cycles? What does it mean for like stars, galaxies, and well, us?
Exactly. All fantastic questions. And I think that's a perfect place to pick up in our next part. We'll dive deeper into those implications. What do you think?
Absolutely. This is already mind-blowing stuff, and I can't wait to see where this deep dive takes us next. All right, so we've got this picture of the universe constantly expanding and contracting, kind of like breathing.
Yeah, this cosmic dance driven by wave synergy.
Right, wave synergy. But what about, like, black holes?
Ah, yes. Black holes.
They're usually seen as these, like, destructive forces, just swallowing everything up.
Right, cosmic monsters.
Yeah, but I have a feeling this Grand Fibonacci theory might see them a little differently.
You're on the right track. The Grand Fibonacci theory actually gives us a totally new way to think about black holes and their role.
Okay, I'm hooked. Tell me, how do black holes fit into this whole cosmic dance thing?
So instead of being these like agents of destruction, the theory suggests that black holes might actually be essential for the universe to keep, well, cycling.
Hold on. So black holes are like the good guys. They're helping to keep the universe going.
Think of them more like crucial regulators.
Okay, regulators.
Yeah, remember those fluctuations in energy density?
The ones that drive the expansion and contraction.
Exactly. So black holes, with their massive gravitational pull, they might actually play a key role in, like, regulating those fluctuations.
Okay, I see. They kind of keep things balanced.
Yeah, like a cosmic balancing act. They gather energy and matter during the contraction phase, and then they release it back into the universe when it's expanding.
So they're like these cosmic recycling centers.
Perfect way to put it. Helping to redistribute all that energy and matter throughout the universe.
Wow, that's amazing. It totally changes how I think about black holes. But what about us?
Right, where do we fit in?
Yeah, like humans, life in general. How does all that work in this grand cosmic scheme.
That's where things get really, really mind-blowing, because if the universe is this interconnected system driven by these wave patterns, it makes you wonder about life and consciousness, you know?
You mean, like, is the universe conscious? Are we all just part of some giant cosmic mind?
Well, those are big philosophical questions that the theory doesn't exactly answer. But it does suggest that life and consciousness might not just be random accidents. They might be emergent properties of this wave synergy we keep talking about.
So instead of life just popping up randomly, you're saying it could be like a natural outcome of how the universe is structured.
Exactly. Imagine those wave patterns interacting, getting more complex over billions of years. So the Grand Fibonacci theory suggests that this whole complex interplay could create the perfect conditions for life to emerge.
So the universe is kind of like predisposed towards creating life?
It's like the universe has this built-in tendency towards complexity and self-organization.
Okay.
And life, well, life is just one of the most incredible examples of that tendency.
Wow, that's a pretty amazing thought.
Right. It suggests that life might actually be a fundamental feature of the universe, not just some random fluke.
It definitely is. But where does consciousness fit into all of this? Like, how does a wave pattern or an equation lead to, well, awareness?
That's the million-dollar question, isn't it? It's puzzled philosophers and scientists forever.
Yeah.
And the Grand Fibonacci theory doesn't have all the answers, but it does give us a new way to think about consciousness.
Okay, what kind of new way? What does it say about how consciousness might come about?
Well, think back to the fractal nature of the universe. The same patterns repeating at different scales.
Right, the snowflake thing.
Exactly. So the Grand Fibonacci theory suggests that consciousness might be another expression of that fractal pattern, but on a super, super complex level.
So you're saying, like, our minds, our experiences, they're like these incredibly intricate knots in that cosmic tapestry.
That's a beautiful way to put it. It's not saying our minds are literally made of waves, but that the same principles at play might be governing both.
So our brains are like tapping into this huge cosmic network of information, energy, and somehow translating that into our experience, our consciousness.
Something like that. It suggests this deep connection between our minds and the universe, a connection we've maybe only just started to understand.
Okay, now my brain is really starting to melt. If our consciousness is linked to this cosmic network, does that mean we're all connected to each other too?
That takes us into some pretty speculative territory, but it's definitely a possibility. I mean, if the universe is truly one unified system governed by these same principles, it's not crazy to think our minds might be part of that unity.
That's a pretty profound thought. It's like a level of interconnectedness we haven't really grasped before, but it makes you think about what it means to be human.
Right.
Our responsibility to each other, to the universe itself.
Exactly. And that takes us beyond physics and into ethics, philosophy, spirituality. The Grand Fibonacci theory isn't just about understanding the universe out there.
Right.
It's about understanding our place within it, how we should live with this new understanding.
So it's not just a theory, it's like a call to action, a challenge to rethink how we relate to the universe and each other.
Absolutely. And that's what makes it so exciting. It's not just an intellectual exercise.
Yeah.
It's a potential roadmap for a better future, a more harmonious and sustainable one for everyone.
This is some seriously deep stuff. I think we need a minute to just process all this before we jump into those ethical implications.
Yeah, let it sink in.
Ready to explore what it means to live in a universe governed by this Grand Fibonacci theory.
Let's do it. The journey's just beginning.
All right, so we're back, and I gotta say, this Grand Fibonacci theory has really, like, flipped my world upside down.
Yeah, it's a real head trip.
We went from talking about black holes as these cosmic recycling centers to, like, consciousness being part of this wave synergy.
It's a lot to wrap your head around.
It really is.
Yeah.
But what I find really interesting is that it doesn't stop at just explaining the universe. It also gets into, like, the ethical side of things.
Yeah, that's one of the most fascinating aspects of it, isn't it? It forces us to think about what it all means, how we should live in a world that's governed by, well, such deep interconnectedness.
So it's not just about figuring out how the universe works. It's about, like, figuring out how to live in it responsibly.
Exactly. If we're all truly connected, as this theory suggests, then everything we do has consequences that go way beyond ourselves. It challenges us to shift away from this me-first mentality.
To more of a, like, global responsibility kind of mindset.
Yeah. Precisely. We're all part of this intricate web, this cosmic tapestry. And what happens in one part of the web, it affects the whole thing.
Okay, I can definitely see how this theory would lead to like a more environmentally conscious perspective.
Hmm.
But how does it apply to things like social justice or global cooperation? Those seem pretty different.
Well, if we really take this idea of interconnectedness seriously, it means that the well-being of others is directly tied to our own.
Oh, interesting.
Injustice anywhere, it ultimately creates instability everywhere.
To make sense.
It's like pulling on one thread of that tapestry. The whole fabric gets distorted.
All right, it all kind of unravels a bit. So you're saying that promoting things like equality and fairness, it's not just about being nice, it's about ensuring the stability and harmony of the whole system.
Exactly. It's about understanding that each of our actions contributes to the overall health of this web of life. Everything from how we treat each other to how we manage our resources, care for the planet, it all plays a part.
That's a pretty huge shift in perspective. It's like we're being asked to become guardians of this cosmic tapestry, making sure the weaving stays strong and vibrant.
Guardians, stewards, yeah, I like that. Is a big responsibility.
And it seems pretty daunting, to be honest. Where do we even start with something like that?
I think it starts with awareness. Recognizing that our choices, big or small, they have ripples that extend way beyond ourselves.
Okay.
It's about pausing, asking ourselves, does this action that I'm about to take, does it add to the harmony of the system? Or does it create more disharmony and imbalance?
So making choices that align with this idea of cosmic interconnectedness. But how do we know what those choices are? Like, life's messy. There aren't always easy answers.
You're right. It's not always clear-cut. But I think the grand Fibonacci theory can serve as a kind of guiding principle.
Oh, okay.
It encourages us to look past just our own immediate self-interest and consider the well-being of the whole, the long-term impact.
So expanding our circle of concern from me to we.
Yes. Cultivating a sense of responsibility for all life on Earth and for the planet itself, and recognizing that this responsibility, it's not a burden, it's an opportunity.
An opportunity for what?
To participate in something much larger than ourselves, to contribute to the flourishing of this amazing interconnected web.
It's like we're being invited to join this cosmic dance.
I love that analogy, the cosmic dance.
We can become active participants in creating a more harmonious and flourishing universe.
And that's a pretty inspiring thought, isn't it? This theory offers a vision of a future where science and ethics, individual action and collective responsibility, they all come together.
To create something beautiful, something sustainable.
Yeah.
Wow, this deep dive has really given me a lot to think about. It's changed how I see the universe and my place in it.
And that's the power of a truly groundbreaking theory, right? It doesn't just add to our knowledge, it changes how we understand who we are, what our purpose might be in all of this.
Well, we've reached the end of this deep dive, but before we go, I want to leave you with this. If the universe really is this interconnected web of energy and matter, as the grand Fibonacci theory suggests, then each of us has a part to play in how this story unfolds.
And that story's still being written. This theory is just one chapter. It's an invitation to explore, to question, and to add our own unique thread to this amazing cosmic tapestry.
So keep asking questions, keep exploring, keep looking for those connections that tie us all together. Until next time, keep diving deep.